All right, moving on to example 2, we're going to use one trig ratio to find another. Actually, we're going to use one trig ratio to find all of the other trig ratios, not just another one. So if we know that the tangent of theta is equal to 15 over 8, believe it or not, that's enough information for us to get the 5 other trig functions, trig ratios. Let's start by drawing a triangle. We know that we're working with a right triangle. Maybe it looks something like this. Here's my right angle. We know that theta is one of our angles, so I'm just going to go ahead and maybe I'll put theta up here. So that's our angle that we're going to reference. And then we also know that the tangent of theta is equal to 15 over 8. So these are the things we know. Oh, we know a little bit more. Tangent, so ka toa, tangent of theta is the opposite side divided by the adjacent side. What am I writing? Okay. Remember, so ka toa, opposite over adjacent. So what that tells us, since they already gave us the trig ratio of 15 over 8, that means the opposite side of theta must be 15 and the adjacent side of theta must be 8. So we can go to our picture and go ahead and label those sides. Opposite of theta is going to be right here, 15. The adjacent side is not the hypotenuse, so it must be this side, the one next to our angle. So we have 8 there, and now we just need the hypotenuse. Do you guys have any way to find the third side of a right triangle when you know 2 of your sides? And you know what? You do. Remember this guy? A squared plus b squared equals c squared. That's our Pythagorean theorem. So we can use the Pythagorean theorem. Just remember, of the 3 sides of your triangle, the hypotenuse has to be your side C. So we can go ahead and plug in 8 squared plus 15 squared equals c squared. 8 squared plus 15 squared, if we do that math, we get 289 equals c squared. Then you square root both sides and we get side C is equal to 17. So I'm going to come up here and there's 17. Well, we've got 3 sides of our triangle. We know where theta is. We can find our 6 trig functions. So we start out with sine. Sine of theta is equal to the opposite over the hypotenuse. Oh, how about if we label our triangle? That might be a good idea. We should have done that when we talked about it earlier. We said 15 was the opposite side, 8 is the adjacent side, and 17 is our hypotenuse. All right, so now we can just do a quick glance at our triangle, find the opposite side, 15, over the hypotenuse, 17. Does 15 over 17 reduce? Does not, so we'll just leave it like that. Cosine of theta is the adjacent side over the hypotenuse, so our adjacent side is 8 over the hypotenuse of 17. And then we have tangent of theta is the opposite over the adjacent, so opposite is 15 over the adjacent 8. All right, so those are the 3 main trig functions that we hopefully remembered a little bit from geometry. Now we're going to get the reciprocal trig functions. So the reciprocal of sine is not the one that starts with an S, it's the cosecant. Cosecant of theta is the reciprocal, so 17 over 15. The reciprocal of cosine is not the one that starts with a C, it's the secant, S-E-C. Secant of theta is 17 over 8, it's the reciprocal of our cosine. And then the easy one, reciprocal of tangent, is cotangent of theta equals the reciprocal, so 8 over 15. And there's all of our trig functions. Again, all we knew was tangent of theta was equal to 15 over 8. We kind of drew out the information we knew, and that was enough to get all the rest of our trig values. Do you notice how Pythagorean theorem worked out perfectly? Our 2 sides squared equaled a number that was a perfect square, so we got this nice clean 17. When that happens, we call those values Pythagorean triples. So I want you to add into your notes Pythagorean triples. What a Pythagorean triple is are three numbers that represent the three sides of a right triangle that work perfectly in Pythagorean theorem. So a very common Pythagorean theorem, or excuse me, Pythagorean triple is 3, 4, 5. We always put the largest number on the end, so that would be our hypotenuse. So if we had a triangle with side lengths 3, 4, and 5, 3 squared plus 4 squared equals 5 squared. Where this is helpful is, let's say the tangent of theta was 3 over 4. If we knew our two side lengths were 3 over 4, we wouldn't even have to do the Pythagorean theorem if we just knew that it was part of a triple, that 5 had to be the hypotenuse. So I just wanted you to have in your notes some Pythagorean triples, so maybe we don't have to do this work every time if we recognize when a triple shows up. Another common Pythagorean triple is 5, 12, 13. Another one is 7, 24, 25. Another one is actually what we just had one. We didn't call it a triple because I wasn't bringing it up till the end. 8, 15, 17. So 8 squared plus 15 squared equals 17 squared. 7 squared plus 24 squared equals 25 squared. If you don't believe me, try it out. See if it works out. So if you have a right triangle with any two of these three sides in this groupings, then we can just say, I already know what the third side is. I don't even have to do the Pythagorean triple. I'm sorry, I don't even have to do the Pythagorean theorem. Just make a note also that multiples of these work as well. So multiples work also. So what I mean is, like that 3, 4, 5, if we doubled all of those, multiplied them all by 2, 6, 8, 10, that would work out in the Pythagorean theorem as well. If we multiplied them all by 3, if we had 9, 12, 15, it's basically like a triple that's not reduced. This would reduce down to the 3, 4, 5. But if I was given 9 and 12 as two side lengths of a right triangle, I already know the third side would be 15. I don't even have to do that Pythagorean theorem.